Night air bites at your exposed faces as you trudge through knee-deep snow, your breath forming crystalline clouds that dissipate into darkness. Above you, aurora borealis paints green ribbons tracing undulating planetary magnetic field lines. You check global positioning system unit strapped to your wrist. 2 more kilometers to sampling site. Our thermal suits are white with gray camouflage patterns, so they hold up well against 30 degrees, but we cannot afford to linger. Elana nods, adjusting her backpack straps. Magnetic disturbance readings are getting stronger. This aurora activity might be exactly what we need to capture correlation between geomagnetic fluctuations and cryospheric anomalies. You track phenomenon to understand how dancing lights overhead affect solid element 1 to the 2-6 composition. Samples show microscopic changes in crystalline structure during peak auroral activity, which are not explained by conventional glaciology. Elana points to horizon with her gloved hand. Look, intensity is increasing. We need to hurry if we want to catch peak sampling window. You nod, picking up your pace. Special collection tools clink against each other in your pack. Precision cryosampling devices designed to preserve ice's quantum state during extraction easily withstand commotion. You navigate around a particularly deep drift. How is core extractor calibrated? Elana pulls out a thin rod with glowing blue tip. Set for micro extraction at 3 centimeter intervals. Thermal buffer is active, so we will not contaminate samples with our own heat signatures. Snow crunches beneath your boots as you approach ridge overlooking sampling field. You see pristine expanse of untouched white, illuminated by dancing green curtains overhead. Snow crunches beneath your boots as you approach ridge overlooking sampling field. You see pristine expanse of untouched white, illuminated by dancing green curtains overhead. Aurora's reflection on snow creates otherworldly glow, as if ground is phosphorescent. Elana points to patch where snow shimmers differently. There, that is our spot. We carefully make our way downslope with deliberate movements to avoid disturbing surface more than necessary. Scientific precision is everything in this work. You kneel down, removing your pack to extract black carbon fiber collection container lined with superconducting material to maintain quantum coherence. Ready with first sampler. Elana takes out her precision tool, its transparent chamber glowing faintly blue. Remember, we need to synchronize with auroral peaks. Watch wave patterns. We both look up at the magnificent spectacle above us. Green ribbons intensify, joined by hints of purple at their edges, which is evidence of heightened stellar particle interaction with upper atmosphere. Alana's eyes are locked on specialized aurora monitor clipped to her suit. Now this is wave peak. You plunge sampler into snow, triggering quantum preservation field. Device hums softly as it extracts precise state of ice during auroral peak, capturing data about atomic alignments and quantum entanglements that might explain anomalous readings previously detected from satellite scans. Sampler's chamber fills cylindrical core gleaming white. You carefully transfer it to collection case, where it locks into place with satisfying click. You are unable to keep excitement from your voice. Perfect extraction. Integrity readings are at 99.8%. Alana's eyes crinkle with a smile beneath her frost-covered scarf. Let us get full spectrum models to predict 3 more peak waves before aurora diminishes. For next hour, you work in synchronization, taking samples at carefully timed intervals, documenting each extraction with multiple sensors. Aurora responds to your work, brightening then dramatically just as you extract crucial samples. As you prepare final core extractor, brilliant surge of green light washes over landscape, so bright it casts shadows despite night. In that moment, snow beneath your feet glows. Ground level response is stronger than we predicted. Get spectral camera. We must observe this. As Elana fumbles with specialized camera, you quickly take final sample from exact spot where snow responds to aurora. Carefully securing sample. This could be it. A missing link between magnetospheric dynamics and cryospheric response. If these samples show what we think they will, it explains how plasma systems communicate with each other. When auroral surge subsides, you pack your cargo securely. 12 perfect cryo samples, extracted at precisely right moments, preserved in their quantum state, potentially holding answers to scientific questions awaiting transportation. Securing collection case to your pack. Mission accomplished. Let us get these back to the lab while preservation fields are at full strength. You trek back to your research station, pausing to look at aurora. Green ribbons wave farewell. Elana pulls down her scarf briefly, her breath immediately crystallizing in frigid air. Do you ever think about how many generations of humans have looked up at these lights? How many theories they inspired? You nod, feeling small beneath the vast sky. With renewed purpose, you journey back across frozen landscape, carrying fragments of frozen time that might unlock natural mysteries. Weather shifts as wind suddenly picks up, howling through valleys with increasing ferocity. Elana shouts over a rising gale. Pressure drop! Blizzard front moving in fast! You look towards horizon where a white wall advances, obliterating everything in its path. We need to secure samples and get out of here! You both quickly seal collection cases to secure them more tightly. Wind pelts you with ice crystals, stinging any exposed skin. You pull your insulated hood over your head, then tighten its drawstrings. Elana does the same, her fur-lined hood edges framing her face as she squints against increasing whiteout. Elana taps her device. Global positioning system shows shelter 2 kilometers east. You respond. Visibility's dropping fast. You press on, leaning into wind as temperature plummets further. Snow grows so thick that you barely see 3 meters ahead. You stay close together, occasionally reaching out to grasp each other's arm for stability and reassurance. You shout with forced confidence, through brutal conditionings that were intensifying each second. We have experienced the worst. Elana flashed a determined smile. Remember Electron Hole and Atomic Orbital? How could I forget? You rose high into the sky. Then you jumped after me with all of our equipment. Shared memory makes Howling Storm feel less threatening. Without warning, your foot strikes hidden ice shelf. You pitch forward, arms windmilling, landing face first in a deep drift. Your fall is softened by powder, but you're suddenly half buried. Alana's voice is muffled by Storm as she reaches down to help you. Are you okay? Before you grasp her hand, powerful gust knocks her off balance too. She topples forward, landing beside you in an ungraceful heap. For a moment, you both lay there, partially buried in rapidly accumulating snow. Absurdity of your situation hits you simultaneously. Despite dangerous conditions and precious scientific cargo, you break into laughter. You sputter, wiping snow from your face, only to have it immediately replaced by fresh powder. Some elite researchers we are. Elana laughs so hard she can barely speak. Your face when you went down, like you were personally offended by snow. You sit up, snow cascading from your shoulders. Look who was talking. You did not exactly stick your landing either. Blizzard continues to bury you as you sit there, white accumulating on your shoulders and hoods. We should probably be concerned. Elana agrees, finally getting to her feet, then extending her hand towards you. Probably, but sometimes you have to appreciate absurdity of conducting cutting-edge science while nature humbles you. You grasp her hand to pull yourself up, brushing off snow before it freezes to your suit. Samples are fine, and Storm actually works in our favor as extreme cold maintains quantum preservation field. Elana pulls her navigation device back out, then points in what is apparently right direction, though it all looks the same to you now. Electromigration pattern is unprecedented. Electrons are not just moving, they're being shepherded. You trudge through research station's outer perimeter. Your equipment detects an anomaly before you visually confirmed it. A localized disturbance in quantum field measuring above background levels. Electromigration exceeds critical current density threshold. Elana calibrates scanning tunneling microscope. Look at this. Vacancy concentration is inverting. Her portable display shows electron microscopy readings, where, instead of metal atoms displaced along grain boundaries, atoms assemble into ordered crystalline structures. Electromigration causes atomic displacement, then void formation, eventually leading to circuit failure. These electrons are moving coherently through quantum tunneling gates. You track phase coherence. Overhead aurora spectral signatures match emission wavelengths from quantum field detector. Electromagnetic field is generating standing waves, but harmonics are incoherent. She gestures to deer visible in quantum noise. This manifestation arises when electron movement reaches critical density. It is establishing pathways, creating order through entropy, to maintain phase correlation across distances that should have caused immediate decoherence. Electrons are shepherded through crystalline lattices that are stable at cryogenic temperatures. Your equipment measures electron mobility at higher than any previous rate. Electromigration's antlers are fractal antennas, perfectly matched to background magnetic field strength. It is establishing pathways, creating order where entropy should dominate. Second law of thermodynamics is locally reversed. Your quantum field analyzer detects entanglement patterns extending throughout its form. Decorative patterns on its body are visualizations of electron probability distributions, solving quantum mechanical equations across macroscopic distances. Branching ratios in my antlers follow the same mathematical progression as spiral sequences, but with base 3 numerical system. Look at junction points to precisely match locations of 0 point energy in ambient field. Your data collectors capture femtosecond resolution spectrograms of electron transport, superconducting channels operating at 27 degrees. Electron phonon coupling strength is off charts, but without any detectable thermal signature. Whatever is controlling these electron flows prevents us from manipulating electromagnetism directly. The Arbinger's movement corresponds with shifts in local magnetic field. Each step it takes generate coordinated spin waves through ferromagnetic resonance patterns. You watch quantum coherence stabilize rather than decay. It is enforcing electromigration laws. It is demonstrating controlled manipulation of quantum decoherence. Wave function is not collapsing, despite macroscopic scale and ambient temperature. When Arbinger approaches your equipment, screens displayed spontaneous solutions to differential equations describing electron transport mechanisms, mathematical proofs emerging from what appeared to be noise. You focus instruments on Arbinger's heart, a node where all electromagnetic pathways converge. Current density causes catastrophic electromigration failure at that junction, creating reinforcing electromigration lattice. Electrons move through diamagnetic channels. Electromigration Arbinger movements radiate from their plasma bodies to interact with ambient magnetic fields, generating spiraling energy vortices. What are they doing? Electromigration are catalysts of motion. They migrate along gradients of potential, guiding charged particles to new homes. In their wake, electromagnetic fields reshape, forming scaffolding for structures. Without them, stars would lose their spark, and planets would drift lifelessly. You watch, enraptured, floating alongside electromigration, who is giggling as it flickers in and out of probability states. Interplay of wave and particle, cloud and hole, create localized zone of increased energy density, catalyzing atomic orbital formation.